Good evening, students. Am I audible?
Yes, ma'am.
Okay, what we discussed in yesterday's class? Any doubt? So we were discussing about Unit 4 topics. We discussed trees. Then we started with different types of tree structures. What are the different types of trees we discussed? Have you gone through the Google Classroom? You received the any doubt in trees and types of trees, tree traversal techniques, and implementation of binary search tree? So in yesterday's class, we were
No,
discussing
ma'am.
hashing. Can anybody explain what is hashing? Where the hashing technique is used in real-time scenario? So as we discussed, hashing is it is an abstract data type. It's having its own attributes and user-defined functionalities. So why we are using this particular logic means it is an technique of mapping large chunk of data into small tables using an hashing function. So it is a way of mapping the data through the index or through the metadata. It is also known as message digest function. The hashing function, other name is called message digest function. It is a technique that uniquely identifies a specific item from a collection of similar items. So if you have a number of similar kind of data, those kind of data can be grouped into a tag. The tag can be accessed through the hashing function. It uses hash table to store the data in any format. Each value in the array is assigned with a unique index number. So the hashing values are identified through the key or through the index. The hash tables uses a technique to generate those unique index numbers for each value stored in an array format. So we'll use create an hash table like stack. A hash table is created with a fixed size. Say while creating an array, we are mentioning now it may be a fixed size array or varying size array. If you are going for a dynamic memory allocation, so a memory location is allotted for hash table. So yeah, it always starts from 0 to n. And while storing the values, we won't store as per the index. We will use an hash function. The hash function, because it is a function, it's like mathematical function. We will use in a hashing technique, we are using three different types of functions. One is what are the three types of hashing functions we are using? Division method, mid square method, digital folding. So those three techniques are used very long from the for very long time. That is when the logic is nowadays we are having a number of other advanced techniques also to create the hashing functions and the hash values, but they are all based on the type of project or the type of programming front end and back end what we are using. But in data structures, we are talking about three types of hashing functions. One is division method, another one is bit square method, third one is digital folding. So here we are using a digital division method based hash function. So it is a function, it's having a variable also. So the hash function is represented as h, and it is a function. So we are using h of x. So where x is a variable, we need to find out the value for that variable. Say here our hash function is represented as h of x, where x is a variable. Here x is given the key, hash key is given as, hash key is substituted to x, and division method, we will use the modulus operator so that the remainder will be within the range of 0 to 9. If we go with actual division, we will have a whole part and remainder part. We will take in a division, we will take the whole part as the result, but in case of modulus, the remainder will be taken as the result. So here we want to store the values 11, 12, 13, 14, and 15. These are the values we want to store in the hash table. But here the values will not be stored from 0 index to index 4. So these hash values will be substituted to the hash function h of x, where x takes the value 11. When we would like to store the value 11 in the hash table, 11 is substituted to x. So the expression is x modulus 10. So we'll get 11 modulus 10. What is the value of 11 modulus 10? What will be the result of 11 modulus 10? So 11 modulus 10, the remainder is 1. So the value 11 will be stored in the index position 1. In the same way, while storing the value 14, the 14 value will be substituted to h of 14. So it is equivalent to 14 modulus 10. The remainder is 4. So it will be stored in the index position 14. So here, this logic is called hashing technique. The function, what we are using to calculate the hash value is called hashing function. The value which we are substituting to the hashing function variable is called hash key. So what is a hash table means? It is an table used to store the, it is a data structure, it merely an array. It's same as array because we are allocating memory location of a fixed size containing the keys. A key is a string with associated value. Say for example, here we are taking an hash table size of 5. So 0 to 4, 5 memory locations is assigned to the hash table, and it's having the index position 0, 1, 2, 3, 4. Here we are taking the hash function as h of x equal to key modulus table size. Now we want to store the values, say 21, 18, 32. So these are the values we like to store in the hash table. In this case, when we substitute the value 21 to the hash function, we'll get key is 21, table size is 5. So we'll get the remainder is 1. So the value 1 is stored in the index position. The same way, if you take 32 modulus 5, so the remainder is 2, it is stored in the location, second index position. 18 modulus 5, we'll get the remainder 3, it will be stored in the third location based on the function. So how we can define the hash function means, it takes the key as well as table size. And by taking the hash key and table size, it returns the hash value. So this diagram explains you the logic behind the hashing technique. So we are giving input values. The input values are the keys. These keys are substituted to the hash function. Here we are taking the hash function h of x equal to x modulus 7. So where 7 is based on the table size. The table size ranges from 0 to 6 total. So the table size is 7. So here we want to store the keys 7, 16, 33, and 42. So the, say for example, if you want to save the value 32, h of 32, 33 is equivalent to 33 modulus 7. You will get the remainder as 5. So that 5 is called hash value. So the hash value 33 will be stored in the fifth index position. The same way, when we like to store the value 16, the key value is 16. X of 16 is 16 modulus 7. It is substituted to the hash function. It will produce the hash value as 16 modulus 7, remainder 2. So the 16 is stored in the index position 2. So any doubt what is hashing and what hashing technique? Any doubt? Where we are using this hashing, what is the role of hashing in programming means? The hashing concepts maps the key with the corresponding key values using the hash function. Hash table supports the efficient addition of new entries into the entries, and the time spent on searching for the required item is independent of the number of items stored. See, even the table size is 100 or 200 or 1000 or 10,000. We are not going to bother about, say, depending upon the number of values in the table, our complexity, big O notation and big omega notation differs. Big O for n numbers, the time complexity using normal procedure will be order of n square. But here we are calculating the address hash value, and in the based on the hash value only the values are going to be stored. So it is even the table size is 100 or it is a 10,000, it won't take much. The time is same. So depending upon the throughput is same for varying size of tables. Yeah, hash function is any function that can be used to map data of a arbitrary size to the data of fixed size. As we discussed in the yesterday's class, if you take any book, we can find the table of content or number the chapters after the acknowledgement we'll find the number of chapters. So in the table of content all the chapters will be mentioned and the corresponding page numbers will be mentioned. Say you want to refer the chapter 5, the chapter 5 starts from page number 320 in the textbook. So by referring the index from the table of content, you can directly go to the chapter 4 or chapter 5 where it is starting. The same way, if you want to know more detailed information about a particular topic, if you take the textbook, end of the textbook, you can find the metadata, or we can see the index of all the keywords used in the book. Say the keywords hashing you are searching, nearby the keyword hashing, you can find the number of the different pages where the concept is referred. So it is an easy way of accessing any reading, accessing, adding, deleting, and modifying the data in a very large databases or in a table, hash table of very large size. Because accessing a data in a table size of 10 is almost equivalent to accessing the same data in a table size of 1000 or 2000. So if you are using an hashing function, these are all the various steps we need to follow. We need a key. The key is substituted to the hash function. The hash function will produce an hash value. The hash value, based on the hash value, the key is stored in the hash table. So hashing key, hash function, hash value, and hashing table. The complete mechanism is called hashing mechanism. Any doubt so far? What is hash key, hash function, hash values, hashing table, and the mechanism, hashing mechanism or technique? Any doubt? Shall we start the next unit? Graphs. How many of you joined? Am I audible?
Yes, ma'am.
Shall we start the next unit?
Yes, ma'am.
Because we already covered this topic last 4 classes. Or you want to just revise the trees and hashing techniques? We will start the chapter 5, unit 5, graphs, in the next class. And in hashing, we are using three major
Start
concepts.
the next.
Starting the next. Okay. So have you gone through the syllabus? So if you take the syllabus, I think syllabus and programs list of indicative experiments. I think sorting, searching is over. Linked list to singly linked list to doubly linked list. Then stacks using array and linked list. Queues using array and linked list. In the previous class, we discussed binary tree traversal techniques. Stacks using array also before mid exam, and a linked list sorting algorithm. So I need the observation with all the completed portions. And I will give your mid-exam paper. It's already corrected. I thought of giving it today. So I will give you on Tuesday. So binary tree traversal completed. Binary search tree also we did in the class. And based on hashing, we have one program, last program, 12th program, implementation of hashing techniques. This we need to complete. Then based on the unit 5 graphs, we have breadth first search, depth first search, and Digister's algorithm, Digister's shortest path algorithm, source to destination, and Primes and Kruskal's algorithm. These three programs are based on graphs. And based on the hashing technique, we have implementation of hashing technique using open addressing or so this program also you complete. I think the program is already there in the C programs using DSA programs using C and the C++ programs based on data structures and algorithms concept. So you need to complete the hashing implementation of hashing techniques. So far we were revising the hashing. What is hashing? What is hash function? Hash key, hash value, hash table, and the mechanism. The next topic is introduction to hashing. The next topic is the hashing methods. What are the different methods we have to create the hash keys? Then, if an collision occurs in the hashing technique, that is, if two values are getting the same address, if already some value is stored, and for the next value also, key also, we are getting the same address, whether we will overwrite or we will erase the old one and write, or we will discard the second one. So how to avoid the collision? That is called collision resolution technique. So hashing collision resolution technique, we have two major techniques. Within that, we have three subdivisions. And the same way, the hashing methods, we have three methods: division method, digital folding method, and mid square method. Screen is visible or not? So we were discussing introduction to hashing, hash key as hash value, hashing function and the hash table, hashing mechanism. Then the three hashing function methods and the two major methods of hash collision resolution techniques. Okay, what are the three methods of generating the hashing function means? The first method is called division method, and the second one is called mid square method. Third one is called digital folding method. So hashing division method, the hash function will use the division process. The hashing function will be an division expression. Say we are using arithmetic expression, logical expression, relational expression. No? The same way, here we are using, instead of division, we are using modulus clauses so that the remainder, based on the remainder, we can easily map the hash value with the hash table. So the hash function depends upon the remainder of the division. It's called division method. Here the hashing function is hash key of record modulus table size. Say for example, we are taking an hashing table of 0 to 11 memory, 0 to 10 memory locations. So the table size is 11. Here we want to add the values 12, 16 and 34 into the hash table. What we will do here, the key is, the key we want to store in the table is called 11, 12. So we will substitute the 12 to the key. H of 12 equal to 12 modulus table size 11. So we'll get the expression as 12 modulus 11. The remainder of 12 modulus 11 is 1. So the hash key 12 will be stored in the index position 1. The same way we like to store the value 16. So h of 16 equal to 16 modulus table size 11. So we'll get the expression 16 modulus 11. The remainder is 5. So the value key hash key value 16 is stored in the index position 5. When we use the expression hash key expression using modulus process or division process, that method is called division hashing division method. The same way, the hash key can be generated by using mid square method also. In mid square method, what is the logic behind that means? In this mid square method, the key is squared and the middle or mid part of the result is used as the index. Say for example, consider if you want to place the record, we want to store the record value of 3111. Then for the hash table size of 1000, so we have a hash table of 1000 memory locations 0 to 999. So in that case, how we are calculating the hash key and hash key using the hash function means, so the key is 3111. So it is in mid square method, the key is squared. So the 3111 is squared. We are getting the result as 96,783.21. So it means 9 lakhs, 96 lakhs 78,321. So it is an almost 7-digit number. In the 7-digit number, we have to take the mid part of the result. So to take the mid part of the result as the hash key value, we will discard the first two digits and last two digits. The middle 3 digits 783 is taken as the hash value. So in the 1000 memory locations hash table, in the index position of 783, we are storing the value 3111. So any doubt in what is mid square method? Take the hash key, square it, take the middle digits of the squared value. That will be the password, or we can say the index where we are going to store the actual key. The same way in digital folding method, if the number is very long, if you want to create the hash key value for the corresponding long digit, say a value of 16 digits or a value of 10 digits. Say for example, you want to preserve your credit card or debit card 16-digit numbers. So in that case, Where to store, how to store in check which secure place we can store means, say the key is divided into separate part using some simple operation. Those parts are combined to produce the hash key. Say for example, consider a record. The record is the value, it's having the value of almost 8 digits: 123, 654, 12. So for this, to store this value, how we can apply the digital folding method means, the digit is of 12, 8 digits. What we can do, we can make an hash function in such a way that hash of key equal to the first three digits plus next three digits plus last two digits. So we are taking 123 plus 654 plus the next two digits. If you add all together, we are getting some value. In that particular hash key value, a table of around 1000 memory locations or something. This value will be, the key will be stored. As we discussed in the classroom, say for example, you want to store your, want to set some password or hash key to some secure data. What we can do, we can take our date of birth, we can add the ddmmyy, and that will produce an minimum 4 digit number. That number can be used as an hash key. So that kind of the particular logic is called digital folding method. So any doubt in what is the division method, hash mid square method, hashing, digital folding method? The next sub topic is called hashing collision. What is collision means? When an element is added, it hashes to the same value as an already inserted element, then it produces collision. So we are trying to add an value in the memory location, but in the memory location is already occupied. It is some other value stored in that memory location. Then the new element also to be stored in the same memory location, then collision will occur. In the those kind of situation, how we can overcome the issue or how we can resolve the collision means, especially in the hashing collision techniques, we have two methods. First one is called separate chaining method, or second one is open addressing method. The separate chaining method is called as external hashing. So external hashing means when we are storing the value in the, we will have the primary hash table, and the primary hash table will have link to the another another list of another buckets of one more linked list. So we can say it is a two-dimensional array. The first dimension is representing the primary hash table, and that is linked with another list of another buckets of or slots of memory locations or arrays where we are storing the duplicate values of which are having the same memory locations. In open addressing, we have three internal types: linear probing, quadratic probing, and double hashing. The linear probing means if the memory location is already occupied, the value which we want to add into the hash table, the hash key location is already occupied, then we will go to the next available memory space. And the second location also occupied means you try the next one. So one by one, if it is occupied, try the next empty or available memory space. So that is called linear probing. If it is quadratic probing, here you are using multiple quadratic equations or quadratic hashing functions to add the hash values. In double hashing, as we discussed, first we'll use the h of x. The h of x memory location is already occupied means you take the 2h of x. The 2h of x hashing function, that address also already occupied means use x, 2x, 4x, 3, 8x, like that. You will double the hashing function. So if you are using linear method, one by one, if you search and if you take the next available memory space, that is called linear probing. If you use a quadratic function, then it is called quadratic probing. In double hashing, we'll use the first hashing method. It's already occupied. Try the second hashing function, 2 hash, 3 4 3 hash, 4 hash, like that. So in case of a separate chaining, how we are storing the values, how we are avoiding the collision means separate chaining is in collision resolution technique to keep the list of all elements that hash has the same value. This is called separate chaining because each hash table element is a separate chain or linked list. In each linked list contains all the elements whose hash key values are having the same index. Say for example, we are having a hash table with 0 to 12, total 13 memory locations. Table size of the hash table size is 13. And we like to add the following numbers into the hash table. The values, keys are 18, 54, 28, 25, 20, 41, 38, like that. So what we will do, we are taking some division method, or we may be using a digital folding, or we may be using the mid square method also. So the key is substituted to the function. And say for example, we are taking the division method for the key 18, we are getting the remainder as 18 modulus 13, we will get the remainder as 5. The 5 location is here. We want to store the 18 in the fifth index. So we will create a link to the fifth index, and one more list will be created. In the list first location, we are storing the 18. The same way we want to store the 54. 54 modulus, the hash size, table size is 13. We will get the remainder as 2. So here the 54 will be stored in a separate linked list. As we mentioned, a separate chain of linked list is generated. Here we are storing the value 54. Again, if you take the 24, 24 modulus 13, we will get the remainder as 2. But the 2 is already occupied by 54, but it's not occupied in the actual index position. A separate chain is created. So we'll add one more node into the linked list. So the 28 is stored. Again, if you take 25, 25 in the remainder is 12. So that is stored in the separate chain. And if you take 41, 41 modulus 13, we will get the remainder as 2. Already two values, 54 and 28, are having the same index value, 2. But the third element, 41, also having the same hash key value 2. Here, we will attach one more node like a linked list. And the 41 is added in the third location of the index is 2, but in the separate chain or in the linked list attached with the index 2, the 41 is attached. So in separate chaining, we are maintaining one dimensional array. Along with that, we are parallelly maintaining a linked list where the indexes are corresponding to a number of linked list nodes. So what is the advantage of separate chaining means? It is simple to implement because we are using linked list concept here. So the adding and deleting and searching for any element is easy through the address because it will be maintaining the forward address as well as the reverse address. Hash table never fills up. So with the, say in the index position 2 itself, we can attach another 100 elements or 200 elements as a separate slot. And less sensitive to hash function or load factors. So here load factor means how many elements are at in the index position 2 itself, how many links are attached, how many, what is the load of index 2, what is the load of index 5, what is the load of index 10. So how many in the separate slot, how many nodes are attached. It is mostly used in the unknown how many and how frequently key may is added or deleted. So when we don't know how many nodes will be added into the table, so if the table size is here only 13, but irrespective of the table size, each index can carry another 100 or 200 linked list nodes. So when you don't know how many nodes will be, how many values you want to store in the hash table, maybe 10 or 100 or 50, irrespective of the number of nodes. When the uncertain situation occurs, in that case, we can make use of this separate chaining method. Here, the performance evolution of separate chaining is M is the number of slots, say the external slots what we are attaching in the hash table. N is the number of keys. Number of keys means the table size, and load factor is alpha is equal to n by m. So where m is the number of keys divided by the number of slots. The expected time to search an element in the separate chaining is big O of 1 plus alpha, where alpha is n by m, n is the number of keys, m is the number of slots. So in here, the number of keys is 13. Number of slots may be depending upon the nodes what we are going to add. The expected time to add and delete the node in the separate chaining hash table is big O of 1 plus alpha. And the time complexity to search and for insertion and deletion process is order of 1. And load factor alpha is also order of 1. The second method is called open addressing. The meeting will end in another 3 minutes. I will take the attendance from the Google Classroom to go through the topics and upload the assignment what I gave. I told you now, differentiate and analyze the various tree structures like general tree, binary search tree, and AVL tree, B tree, NRA tree, B plus tree, and decision tree, expression tree, Splay tree, and red black tree. Based on the definition, diagrammatic representation, the operations what we can perform, advantages, disadvantages, that is pros and cons of the various tree techniques. What is the logic behind each tree structure, and what are the constraints, or what are the characteristics or attributes that differentiate one tree from another tree, and the real-time projects where we are using those kind of logic. So with respect to those parameters, you need to create a table and you have to explain those tree structures. The same way, evaluating an expression tree and generating an pre-order, in-order, and post-order. Prefix, infix, and postfix notations of a given arithmetic expression using expression tree. And you have to write in C or C++ or Python program. The third question in the assignment is, I think yesterday's class, many students absent. So for them, I am telling the questions. Third question is, what is hash function and hash key? And what is the logic behind the hashing technique? Mention the 3 methods of hashing and how the hashing collision is resolved using open addressing and the 2 methods, open addressing and separate chaining method. So these are the 3 questions you need to write handwritten in a table form. The same scan and upload in the Google Classroom. So in open addressing, what we will do? So it is also collision resolution strategy in which we will use alternative cells. So if the one cell is occupied, then you go to the next cell. Say for example, we want to add the element 15. Here, according to this, the table size is 0 to 10, 11, and our key is 15. 15 modulus 11, we will get the remainder as 4. But the cell 24 is already occupied by 24 because its remainder also 4 only. 26 modulus 11 is remainder 4. So we'll if the location is already occupied, we'll go to the next location because it is linear. Linear means what? 1 by 1. Uh, uh, plus 1 plus 1 plus 1 like that, I plus 1 or I plus plus. So we will check the next location. The next location also already occupied by 5 because the remainder for 5 modulus 11 is it's already occupied. We will try the next one that is also occupied. We will try one more time that is also occupied. Now the next location 8th index is empty. Now the value 15 will be added in the 8th index position. So that is called linear probing. The same way in quadratic probing, what we will do, it is also an open addressing strategy where we will use iteratively try. It is also an iterative process. If the location, hash key location is already occupied by some other value, what we will do, we are using to try the next location, we are using a quadratic function a of h of k equal to f of I modulus n, where f of I